Energy. Life is impossible without energy. The demand for energy is ever increasing. Where do we get energy from? The sun is the biggest natural source of energy to us. The word energy is very often used in our daily life, but in science, we give it a definite and precise meaning. The ability to do work is called energy. An object having a capability to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. The energy possessed by an object is thus measured in terms of its capacity of doing work. If we talk about the SI unit of energy, it is same as that of work, that is joule. 1 joule is defined as the energy required to do 1 joule of work. But sometimes a larger unit of energy called kilojoule is also used, and 1 kilojoule equals to 1000 joules. Forms of energy. Luckily, the world we live in provides energy in many different forms. The various forms of energy include mechanical energy, such as potential energy and kinetic energy. Energy is also present in the form of heat energy, chemical energy, electrical energy, and light energy. Let's discuss about the kinetic energy. Objects in motion possess energy, and we call this energy as kinetic energy. For example, a falling coconut, a speeding car, a rolling stone, a flying aircraft, flowing water, blowing wind, a running athlete, etc. possess energy called kinetic energy. In short, kinetic energy is the energy possessed by an object due to its motion. As the speed of an object increases, its kinetic energy also increases. Expression of kinetic energy. Consider an object of mass m moving with a uniform velocity u. Now, let that object be displaced through a distance s when a constant force F acts on it in the direction of its displacement. Then the work would be done, and that work done W is equal to F into S. The work done on the object will cause a change in its velocity. Let us suppose that the velocity changes from u to v, and let A be the acceleration produced. So, if we use the third equation of motion as v square minus u square is equal to 2as, we can find the expression for s, that is s is equal to v square minus u square upon 2a. And now we will substitute the value of f and s in the following equation. W is equal to f into s. So we get W is equal to m into a into v square minus u square upon 2a. Or we can also write it as W is equal to half of m into v square minus u square, as a and a gets cancelled. If the object is starting from its stationary position, then u will be equal to 0. Therefore, we can write W is equal to half of mv square. Therefore, the kinetic energy possessed by an object of mass m and moving with a uniform velocity v is expressed as Ek is equal to half of mv square, where Ek represents the kinetic energy. Potential energy. The potential energy is basically the energy stored in an object to perform various future works. The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. For example, when you stretch a rubber band, the energy transferred to the band is its potential energy. You do work while winding the key of a toy car. The energy transferred to the spring is stored as potential energy. Potential energy of an object at a height. We know that an object, when it is raised through a height, it will increase its energy. Why is this so? This is because work is done on it against the gravity while it is being raised. The energy present in such an object is called gravitational potential energy. Thus, we can define the gravitational potential energy of an object at a point above the ground as the work done in raising that object from the ground to that point against gravity. Let us consider an object of mass m and let this object be raised through a height h from the ground as shown in the figure. A force is required to do this. The minimum force required to raise the object is equal to the weight of the object, that is mg. The object gains energy equal to the work done on it, and let that work done against the gravity be represented by W. Therefore, W will be equal to force into displacement, which in turn become mgh. Since work done on an object is equal to mgh and energy equal to mgh units is gained by that object. This is called the potential energy of the object, and we can represent potential energy as EP is equal to mgh.